1 lesson 14, we're going to focus on solving inequalities as opposed to where the last lesson we worked on solving equations. So this time the instructional outcomes will be to interact with a partner to learn if-then moves using the addition and multiplication properties of inequalities to be able to solve inequalities. And then number 2, we're going to follow up with the ability to be to graph the solution sets on a number line. So example 1 brings us an inequality. It's a two-step inequality where it says 5q plus 10 is greater than 20. They want us to be able to express the solution set in words, to provide it in set notation, and then to graphically represent the solution on a number line. It is important to note that for the most part, solving an inequality is the same as solving an equation. The only difference you want to be careful of is there's a rule that states that if I cancel, and we'll write it right here, if I cancel with multiplication or division and the value is negative, then I need to flip or reverse the inequality sign. Now, if we take a look at this problem here, for example, I may start by saying, well, if I want to solve for q, I'm going to subtract 10 on both sides. So when I subtract 10 on both sides, I now have 5q is greater than 20 minus 10, which is 10. So we would ask ourselves if I need to flip the inequality sign or not coming up at this next step. So it says if I cancel with multiplication or division. So here we go. I'm going to cancel by division. So check. And the value is negative. Well, the 5 here is positive. It's not negative. Then I reflip the inequality sign, but since it's positive, we will leave it alone. And so I cancel this, and q will remain greater than, we will not reverse the sign, 10 divided by 5, and that will equal 2. So in words, we might want to say q is greater than 2. In set notation, we would just leave it as q is greater than 2. And if we want to represent this on a number line, we'll draw a line. And since we're talking about 2, we'll place 2 right here in the middle. We'll provide a few extra numbers on the left and the right just to help indicate direction of what's happening. So this is a 1 and this is a 0. And so if q is greater than 2, when we build our piece, we're going to put an open circle on 2, and then we're going to shade to the right everything that is greater than 2. So it might be important to note, just as a review lesson real quick, the difference between when to use an open circle versus what is known as a closed circle when it is filled in. If we're using the signs that is greater than or less than, we'll use an open circle. We'll use a closed circle if it's greater than or equal to, or if it says less than or equal to in that perspective. So to follow up, the students are given an opportunity to work in pairs. The teacher will probably hand out whiteboards so they can work as a partner and hold up their answer for quick formative assessment of the student. And so we're looking at 5 different examples here with various different things occurring in it. And so if we looked at, let's say, letter A, this is x plus 4, so I would subtract by 4 on both sides. And so then my answer is going to end up being x is less than or equal to 3. And so if we wanted to graph the number line on this, we would draw the line. Again, I would put 3 in the middle. We'll do a 4 and a 5 on this side, a 2 and a 1. And so if we're trying to note what's happening, this is an x is less than or equal to, so we'll use a closed circle, and we're going to shade everything to the left. Now, part B is a little bit interesting. Part B states m divided by 3 plus 8 does not equal 9. So they want to know, in essence, an opposite of what we want to think. Typically, we would want to say, what does m need to be to equal 9? Now, the good news is that while the sign is different, we will take and solve it the same way that we traditionally would solve an equation. So we would minus 8 on both sides. And so m divided by 3 is not equal to 1. We will then take and multiply, because that's the opposite of division, or the undoing of division. So then we'll multiply by 3 on both sides. And so m cannot equal 3. In other words, what we're trying to say in words is that if I were to put 3 in for m, and I did 3 divided by 3 plus 8, that would equal 9. I don't want my equation to equal 9. So when we draw the number line here specifically, and then I got 3 as my solution, which is, again, I will note, not what we want to have, then it's the number lines where we really convey the answer. And so I don't want the answer to be 3, so I'll put an open circle. That means I'm not including that answer, but I am including everything as the answer to the right and everything as an answer to the left. Just not the answer 3, which is why it's an open circle as opposed to a closed circle. In part C, if I'm working through this one, again, we see the situation where we have variables on both sides. So I will subtract 7y on both sides. And when it comes to inequalities, I might add, in class, I always recommend that when possible, students should move all variables to the left. And that's really because in the culture we live in, we are accustomed to reading from left to right. And so if we have that variable on the right-hand side, we will then have to read the inequality backwards. And it's not something that most students are going to want to do. So 8y minus 7y will equal 1y. So we have the plus 4, we have less than, and then negative 2. So at this point, I would subtract my 4 to the other side. And so y is less than negative 6. So if we draw our number line, I'll put it right here at the top. The solution we got was negative 6. So we'll put a negative 7 and a negative 8. We'll put a negative 5 over here and a negative 4, just so we can see the number line pattern occurring. It said y is less than 6. That means it's not equal to 6. It's everything less than 6. So we'll do an open circle and then shade everything to the left. Looking at part D, we see a little bit of distributive property going on. So we'll first start by multiplying by 6, and I'll also show you an alternate route that you can solve this as well. But most students, when they're solving this in class, the first thing that they're going to want to do is they're going to want to multiply by 6. So your typical student is going to write 6x minus 30 is greater than or equal to 30. And at this point, the student's going to add 30 to both sides. That'll give us 6x is greater than or equal to 30. And then I can divide by 6. And that's going to allow x to be greater than or equal to 5. Same thing with the number line. I would have my 5 in the middle, maybe a 6 and a 4, positive 4. And then when I draw the number line, since it's greater than or equal to, we'll have a closed circle and everything shaded to the right in that perspective. When we look at letter E, again, most students will probably start with the distributive property, which is fine. And so we end up with a similar inequality of 4x minus 12 is greater than 2x minus 4. So we'll have the students at that point subtract 2x on both sides. And so that's going to allow us to have 2x minus 12 is greater than negative 4. And if I add 12 to the other side, so plus 12 plus 12, we'll have 2x is greater than 8. I can divide by 2 on both sides. We'll just move this over here. 2x is greater than 8. We'll divide by 2. And x would be greater than 4. So again, that last number line, we have a 4, put a 5 here, and a 3 here. So what will that number line look like? Well, it'll be an open circle. X is greater than 4, and so we'll shade everything to the right.